Hello everyone, and welcome to another video in our IoT for Beginners series. My name is Ariana Lopez, and I am a Senior Solution Architect here at AWS. Today, we are going to focus on IoT design and device, with an emphasis on FreeRTOS and AWS IoT Greengrass. In this video, we will go over the AWS IoT Stack, discuss one of the categories of the AWS IoT Stack, device and design, and then we will look at two of the services under that category, FreeRTOS and AWS IoT Greengrass. For each of those services, we will review what the service is, possible use cases, and the benefits of using that service, as well as when to use which service. And then we will close with a summary. Here is the AWS IoT Stack. At the bottom of the slide, we have our AWS Cloud services. These would be our core services in compute, storage, databases, and more. In the middle, we have our purpose-built AWS IoT services. For purpose-built IoT services, we have three base categories to help customers design for IoT, connect and manage their IoT applications, and analyze and act on data. Under device and design, these services are all about accelerating the development of IoT-enabled connected products. Whether you are working with microcontrollers, or need to enable connectivity on your hardware devices, or simply want to boost your preferred hardware device to process data locally, there are multiple options from AWS that can help offload the functional tasks for you. Now today, we are going to focus on device and design, and in particular, we will focus on FreeRTOS and AWS IoT Greengrass. FreeRTOS is an open source, real-time operating system for controllers that makes small, low-power edge devices easy to program, deploy, secure, connect, and manage. It is distributed freely under the MIT open source license, and FreeRTOS includes a kernel and a growing set of software libraries suitable for use across industry sectors and applications. For those of you not familiar with a microcontroller, according to Wikipedia, a microcontroller is a small computer on a single integrated circuit. It contains one or more CPUs along with memory and programmable input or output peripherals. Microcontrollers are designed for embedded applications. Microcontrollers are also used in automatically controlled products and devices. For example, toys, implantable medical devices, and remote controls, to name a few. FreeRTOS is ideal for resource-constrained devices as it is lightweight and it is a popular choice for embedded systems, including microcontrollers and small microprocessors, where processing power, memory, and power consumption are limited. FreeRTOS can be used in embedded systems spanning industrial, commercial, and consumer applications. One example is smart metering. Smart metering can use FreeRTOS to monitor water usage in real time. So here, the smart meter would have a microcontroller that would have FreeRTOS installed, and then would have software loaded on it that would allow it to monitor water usage at regular intervals and could send that data to the utility company. Another use case would be FreeRTOS used in smart thermostats. By using FreeRTOS, it allows for efficient handling of concurrent tasks, for example, reading temperature sensors, processing user inputs, and controlling HVAC systems. And lastly, FreeRTOS could be used in oil and gas industry. For example, oil pump sensors are used on oil rigs to monitor the output on wells that might be buried deep underwater. An oil rig might deploy FreeRTOS on those sensors, and then use another AWS service, AWS IoT Greengrass Core, to locally process data from pumps and valves in real time. The AWS IoT Greengrass Core could then send batches of pre-processed pump sensor data to the cloud for analytics and data warehousing. Now, there are quite a few benefits by using FreeRTOS. Firstly, it's a kernel. As stated earlier, FreeRTOS kernel is a real-time operating system that is ideal for building embedded microcontroller applications. It is designed to be small, simple, and easy to use. It provides a multitasking scheduler, multiple memory allocation options, inter-task coordination primitives including task notifications, message queues, and more. Secondly, FreeRTOS has the ability to talk to or connect to other devices through various networking connectivity libraries and protocols. FreeRTOS can also connect to the cloud via MQTT to connect to other devices and to send data to AWS. Thirdly, FreeRTOS comes with libraries for security, including secure cloud connection, certificate authentication, key management, and a code signing feature. And lastly, FreeRTOS supports over-the-air updates. So now you don't have to go to each device and manually update the firmware. Now you can use AWS to help with that. So within the AWS IoT Device Management Console, you can provide a firmware image, select the device to update, and create the FreeRTOS OTA job update, and then it will be deployed to the device itself. Now let's take a look at AWS IoT Greengrass. AWS IoT Greengrass is an open source IoT edge runtime and cloud service that helps you build, deploy, and manage IoT applications on your devices. You can use AWS IoT Greengrass to build software that enables your devices to act locally on the data that they generate, run predictions based on machine learning models, and filter and aggregate device data. AWS IoT Greengrass enables your devices to collect and analyze data closer to where that data is generated. It can react autonomously to local events and communicate securely with other devices on the local network. Now, AWS IoT Greengrass can be deployed on the IoT device itself, or it can be deployed onto a gateway device. Now, in the latter scenario, each IoT device would send their data to the gateway device, and Greengrass can then aggregate the data before sending the data to AWS. Greengrass has a vast array of different use cases and can be applied to many different industries. For example, let's say there's a business that wants to monitor the AC units in their building. So we have a smart AC unit that sends data on how it is running. It also sends the current temperature for that floor of the building and what the temp is supposed to be. And then it sends it to the gateway device that has Greengrass installed on it. Greengrass can then aggregate all of that data and send it to the cloud for analysis. And during that analysis, we can then see that the temperature of the building is not within normal parameters. So for example, let's say the temperature is 10 degrees higher. We can then send someone out there to perform maintenance on that AC unit to help with preventative maintenance. Another use case is smart lighting. You can use Greengrass for smart home lighting, for example, turning lights on at a scheduled time. And lastly, in an industrial setting, Greengrass can be used to help with predictive maintenance of machines, similar to our air conditioning example. With the machines, you can send the data to the gateway that Greengrass resides and process the machine data locally and make real-time decisions, or you can have Greengrass send the data to the cloud and analyze it to see if there are any anomalies and determine if certain machines need maintenance. And here we have a few benefits to discuss about Greengrass. Firstly, Greengrass can help with remote fleet management. In AWS IoT, you can create things, which are your IoT devices. In Greengrass, you can create groups and assign your IoT devices to those groups. So if you need to make updates to an IoT device, you can update the whole group and not have to do it one at a time. Secondly, Greengrass allows for local messaging. So you can have your devices communicate with one another locally and not have to use the internet or communicate back to the cloud. Thirdly, Greengrass also helps you with development. Greengrass has a feature called components that are software modules. Some are pre-built, or you can create your own and then deploy to your device for testing. This is to help you accelerate your development. And lastly, just like FreeRTOS, Greengrass also supports over-the-air updates. All you have to do is write the code for it via a component and deploy it to all of your devices. Now that we have reviewed each of the services, the question remains, when do I use one over the other, and what are the requirements for each one? This table here shows the differences between FreeRTOS and AWS IoT Greengrass and when to use one over the other. FreeRTOS is a real-time operating system that runs on a microcontroller. It needs more than 64 kilobytes of RAM, and it is meant for embedded systems and IoT endpoints, or IoT devices. And lastly, its main use case is for microcontroller-based devices. Greengrass, on the other hand, is a runtime for Linux devices and SDK for AWS IoT Greengrass-aware devices. For hardware requirements, it needs more than 96 megabytes of RAM, and it is made for edge devices or local gateways. Use cases for Greengrass are vast and can include industrial automation systems, gateways, video cameras, and many more. Today, we covered a lot of ground discussing two services that fall under the Design and Device IoT category within AWS, FreeRTOS and AWS IoT Greengrass. For both services, we covered what each service is, use cases, and the benefits each service has. We also covered when we would use one service over another. At the end of the day, when choosing between which service to use, it will ultimately depend on your use case. That's all for today. But be sure to come back and join us for our next video where my colleague Kinjal will review the AWS services that fall under the other two AWS IoT categories: Connect and Manage and Analyze and Act. Thanks for joining.